Hi and welcome. Today, I am going to dive into the mystery of the bloop sound. This overview will cover its discovery characteristics, scientific investigations, cultural impact, and related phenomena. Please remember to subscribe, comment, and like. That will inspire me to carry on posting good videos. Let's dive in. The discovery of the bloop. In the summer of 1997, an extraordinary sound echoed through the vast expanse of the Pacific Ocean. This mysterious acoustic phenomenon, later dubbed the bloop, was detected by the U.S. National Oceanic and Atmospheric Administration, NOAA, through its Equatorial Pacific Ocean Autonomous Hydrophone Array. This network of underwater microphones, originally designed to monitor undersea seismic activity and covert nuclear weapons tests, inadvertently captured one of the most puzzling oceanic sounds of the late 20th century. The bloop was first recorded on July 7, 1997, and was detected multiple times throughout that summer. This sound was particularly intriguing because of its unprecedented loudness and organic, almost biological character. The hydrophones, spread over an immense distance of about 5,000 kilometers in the Pacific Ocean, all picked up this powerful, ultra-low frequency sound. Characteristics of the bloop. The bloop was no ordinary underwater sound. Its characteristics set it apart from typical oceanic noises and fueled both scientific curiosity and public imagination. Here are some key features of the bloop. Frequency. The bloop was an ultra-low frequency sound ranging from 15 to 25 hertz. Such low-frequency sounds can travel extraordinary distances in water. Duration. The sound lasted for about 1 minute, rising rapidly in frequency over this period. Amplitude. Perhaps the most striking feature of the bloop was its extreme loudness. It was several times louder than the loudest known biological sound, that of the blue whale. Range. The sound was detected by sensors over a range of about 5,000 kilometers, indicating its tremendous power and reach. Organic quality. Unlike many mechanical or geological sounds, the bloop had an organic quality to it, resembling an amplified biological sound. Uniqueness. At the time of its detection, the bloop was unlike any other recorded underwater sound, setting it apart from known phenomena. Initial speculations and theories. The unusual characteristics of the bloop led to a wide range of speculations about its origin. These theories ranged from the plausible to the fantastical, capturing the imagination of scientists, the media, and the public alike. Unknown marine animal. One of the most popular early theories was that the bloop was produced by an unknown, extremely large marine animal. This idea was fueled by the organic quality of the sound and its unprecedented loudness. Some speculated about the existence of a creature even larger than the blue whale, perhaps a surviving prehistoric animal like a megalodon or a previously undiscovered species. Submarine activity. Given the Cold War era context and the original purpose of the hydrophone array, some initially wondered if the sound could be related to submarine activity, perhaps a new type of sonar or underwater communication system. Geological phenomena. Early considerations also included various geological events, such as underwater earthquakes, volcanic activity, or the movement of tectonic plates. Extraterrestrial origin. In the realm of more speculative theories, some even suggested an extraterrestrial origin, linking the bloop to the idea of underwater alien bases or spacecraft. Cryptozoological creatures. The bloop reinvigorated interest in cryptozoological marine creatures like the kraken or Cthulhu, with some enthusiasts drawing connections between these mythical beings and the mysterious sound. Scientific investigation. The intriguing nature of the bloop prompted serious scientific investigation. NOAA scientists, along with other marine researchers, embarked on a thorough analysis of the sound and its possible origins. Sound analysis: researchers conducted detailed analyses of the bloop's acoustic properties, comparing it to known underwater sounds from biological, geological, and artificial sources. Geographical mapping. The location of the bloop's origin was triangulated using data from multiple hydrophones. It was determined to have originated from a remote point in the South Pacific Ocean, west of the southern tip of South America. Biological considerations. Marine biologists considered whether any known marine species could produce such a sound. While large whales can generate powerful low-frequency sounds, none were known to match the bloop's characteristics. Geological studies. Geologists examined the seafloor in the vicinity of the bloop's origin, looking for any unusual features or activity that could explain the sound. Comparative analysis. The bloop was compared to other mysterious ocean sounds like Julia, slowdown, and upsweep, looking for patterns or similarities that might provide clues to its origin. The scientific conclusion. After years of study and speculation, in 2012, NOAA scientists announced their conclusion regarding the origin of the bloop. Their findings pointed to a much less exotic but scientifically fascinating explanation. The bloop was most likely the sound of a large icequake. Specifically, the scientists concluded that the sound was consistent with the noise produced by the cracking and breaking of large icebergs or ice shelves in Antarctica. This phenomenon, known as ice calving or icequakes, can produce incredibly loud, low-frequency sounds that can travel vast distances in the ocean. Several factors led to this conclusion. Sound profile match. The acoustic signature of the bloop closely matched that of icequakes recorded in other parts of the world. Geographical correlation. The triangulated origin of the bloop coincided with an area known for significant ice activity in the Antarctic. Timing. The summer of 1997 saw increased ice movement in the region, correlating with the timing of the bloop. Power and range. Large-scale ice calving events can indeed produce sounds of sufficient power to travel the distances observed with the bloop. Frequency of occurrence. The sporadic nature of the bloop's detection aligned well with the unpredictable occurrence of major icequakes. This conclusion, while less sensational than some of the earlier theories, provided a scientifically sound explanation for the mysterious sound. It also highlighted the significant impact of climate-related phenomena on the acoustic environment of the world's oceans. The science of underwater sound propagation. To fully appreciate the bloop phenomenon, it's crucial to understand how sound travels in water. The ocean is an excellent medium for sound propagation, allowing certain types of sounds to travel vast distances with minimal loss of energy. Speed of sound in water. Sound travels much faster in water than in air, typically around 1,500 meters per second, compared to about 340 meters per second in air. Low-frequency advantage. Low-frequency sounds like the bloop can travel particularly far in water due to less absorption and scattering. SOFAR channel. The sound fixing and ranging SOFAR channel is a horizontal layer in the ocean where sound waves can travel for thousands of kilometers with little loss of energy. Thermoclines and sound reflection. Temperature layers in the ocean can reflect sound waves, further aiding long-distance propagation. Ambient noise. The background noise of the ocean from sources like waves, marine life, and human activity affects how far sounds can be detected. Understanding these principles helps explain how a sound like the bloop could be detected over such vast distances and why it captured the attention of scientists accustomed to monitoring various oceanic sounds. Other mysterious ocean sounds. The bloop is not the only mysterious sound to have been recorded in the world's oceans. Several other unexplained or intriguing sounds have been detected over the years, each with its unique characteristics. Julia. Detected in 1999, this sound had a rising tone similar to the bloop, but was shorter in duration. Slowdown. Recorded in 1997, this sound lasted for about 7 minutes and gradually decreased in frequency. Upsweep. First detected in 1991, this sound consists of a long train of narrow band upsweeping sounds lasting for several seconds each. Whistle. This sound, detected in 1997, features a single, very long-lasting, whistle-like tone. The hum, a continuous, low-frequency humming noise detected in various parts of the world's oceans, often attributed to human activities. These sounds, along with the bloop, highlight the complex and often mysterious acoustic landscape of the world's oceans, as well as the ongoing efforts to understand and catalog these phenomena. Cultural impact and legacy of the bloop. The bloop, despite its eventual scientific explanation, left a significant mark on popular culture and continues to inspire curiosity about the mysteries of the deep ocean. Media coverage. The bloop received extensive media coverage when it was first reported, sparking public interest in oceanic mysteries. Science fiction. The mysterious nature of the bloop inspired numerous science fiction stories, novels, and films, often featuring giant unknown sea creatures or alien presences. Documentaries. Several documentaries about ocean mysteries and unexplained phenomena have featured the bloop, contributing to its enduring popularity. Internet culture. The bloop became a popular topic on internet forums and social media, spawning memes, discussions, and creative interpretations. Scientific awareness. The phenomenon increased public awareness of ocean acoustics and the scientific study of underwater sounds. Cryptozoology. The bloop reinvigorated interest in cryptozoology, particularly regarding large, unknown marine creatures. Environmental awareness. The eventual explanation of the bloop as an icequake has been used to draw attention to the effects of climate change on polar ice. Importance in marine research. While the bloop itself turned out to have a natural explanation, its discovery and the subsequent research highlighted several important aspects of marine science. Underwater monitoring systems. The detection of the bloop demonstrated the effectiveness and importance of global underwater monitoring systems. Ocean acoustics. The phenomenon increased scientific and public understanding of how sound travels in the ocean and the complexity of the marine acoustic environment. Interdisciplinary research. The investigation of the bloop required collaboration among various scientific disciplines, including marine biology, geology, acoustics, and climate science. Unexplored ocean. The initial mystery of the bloop served as a reminder of how much remains unknown about the deep oceans and the potential for discoveries. Climate change. Indicators. The connection to ice-calving events highlighted how underwater acoustics can be used to monitor and study climate change effects in remote areas. Public engagement in science. The bloop case demonstrated how mysterious natural phenomena can engage public interest in scientific research and exploration. Lessons, learned and future implications. The story of the bloop offers several valuable lessons and implications for future research and public understanding of science. Scientific process. The bloop investigation exemplifies the scientific process in action, observation, hypothesis formation, testing, and conclusion. Importance of skepticism. The case highlights the importance of maintaining scientific skepticism and not jumping to extraordinary conclusions without sufficient evidence. Technological advancements. The discovery and analysis of the bloop have spurred advancements in underwater acoustic monitoring technology. Ongoing mysteries. While the bloop has been explained, it serves as a reminder that there are still many unexplained phenomena in the oceans waiting to be discovered and understood. Interdisciplinary approach. The successful resolution of the bloop mystery underscores the value of interdisciplinary collaboration in solving complex scientific puzzles. Public science communication. The widespread interest in the bloop demonstrates the public's fascination with scientific mysteries and the importance of effective science communication. Ocean exploration. The bloop phenomenon has contributed to renewed interest in ocean exploration and the study of marine ecosystems. Conclusion. The mystery of the bloop stands as a fascinating chapter in the annals of marine science and popular culture. From its initial detection as an unexplained, ultra-loud underwater sound to its eventual explanation as a massive ice quake, the bloop captured imaginations worldwide and spurred scientific inquiry. This phenomenon serves as a prime example of how the unknown can drive both scientific research and public interest in the natural world. It reminds us of the vast, largely unexplored realms beneath the ocean's surface and the potential for discovery that still exists in our world's oceans. Moreover, the bloop's legacy extends beyond its scientific explanation. It continues to inspire curiosity about the marine environment, fuels discussions about the possibilities of undiscovered marine life, and serves as a touchstone for conversations about climate change and its effects on polar regions. As we continue to explore and study the world's oceans, phenomena like the bloop remind us of the importance of scientific inquiry, the value of advanced monitoring systems, and the endless capacity for wonder that the natural world provides. In the end, while the bloop may not have been the call of an unknown sea monster or an alien presence, its true explanation, the sound of colossal ice masses breaking apart, is a powerful reminder of the dramatic and often unseen processes shaping our planet.